So welcome to your first video for Honors Algebra 2. We're in Unit 1, assignment number 1, and the learning targets are solving various types of functions, which we're going to get into today. We're also going to be solving inequalities, and with those inequalities we're going to be learning about what interval notation is. So let's go ahead and get started. If you're watching this video at home, I want you to pause the video and try these two problems first on your own. And then you can restart the video and work through them with me. So if I were to do number 1 on my own here, what I would do is I would want to get rid of these fractions first. And so I would multiply by 12 because 12 is the least common denominator. And so if I multiply by 12, I'm looking for 3/4 of 12. Well, 3/4 of 12 is 9x. I could also do that by taking 12 times 9 divided by 4. Plus, if I take 12 times the 2, that's 24. That's going to equal 2/3 times 12. Well, again, the 12 and the 3 would cancel a little bit out. We can simplify that. But 2/3 of 12 is 8, so that's going to be 8x plus 4 times 12 is 48. And so then I want to get the x's on the same side, so I can subtract 8x over here. 9x minus 8x is just x. If I subtract 24 from both sides, this 24 would be gone, and 48 minus 24 is simply 24. And again, I could check my answer by plugging in 24 into the original equation. So if I took 3/4 of 24, that would be 18 plus 2, that would give me 20 on this side. If I plug 24 in here, then 2/3 of 24, that's 16 plus 4, that also gives me 20. So I know my solution there is 24. Let's go ahead and take a look at number 2. Number 2, what I would probably do here is start by using the distributive property on both sides of the equation. If I take 3 times 5x, that's 15x, minus 3 times 7 is 35, plus the 5, equals 4 times 2x is 8x, plus the 12, 4 times 3 is 12, minus x. So if I simplify both sides, I'm going to have 15x minus 30 equals 7x plus 12. I'm going to go ahead and subtract 7x from both sides. So 15x minus 7x is 8x. This would be gone. I'm also going to add 30 to both sides. So if I add 30 over here, 30 plus 12 is 42. Then when I divide both sides by 8, I would get that x is equal to 5 and 2/8, which is 5 1/4. And I can also write that as 5.25. On our homework assignment today, we're going to be using a program called MathSpace. And one of the things that I want you to know when you use MathSpace is that a number cannot start with a decimal. So for example, if we had an answer like this, we can write it as 5 1/4, or we can write it as 5.25. I believe we can even write it as a mixed or as an improper fraction. We can write it as 42 over 8. What we would not be able to do is, if we get an answer that's like 0.5, we wouldn't be able to write it as just 0.5. It would have to be 0.5. So as you enter your answers into MathSpace, one of the things you're going to want to know or want to remember is that when you have just a decimal, you would have to start with a decimal point. All right. So not only do we have regular equations with the numbers that we're going to solve, but we're going to solve literal equations. A literal equation is an equation with more than one variable that we want to change the subject of the equation. And so the subject of the equation means that we want like x to equal something or a to equal something. If the subject is a, we want the a to be completely by itself. And so again, I'm going to have you see if you can solve this equation. Pause the video, solve this equation on your own, and then you can restart the video to see if you got it correct, if you're watching this at home. So here's what I would do for this equation. I would start by wanting to get the a's on the same side of the equation. So I would start by subtracting a 3a from both sides. Well, that's going to give me a 5a on the right-hand side of the equation, or the left-hand side of the equation. I would move everything else to the other side of the equation. So this is going to equal, I'm going to have a negative 5b over here if I subtract 5b from both sides. I would add 2c to both sides, so this is going to be 14c. And then when I divide by 5, if I divide everything by 5, I would have a equals negative b plus, now 14 over 5, I could leave that as a mixed number, but I'm going to write that as 2.8 C. And this would be my equation with the subject being A. And so we're going to practice those equations. Again, those are both of those things are things that you've done in Algebra 1, and we're just reviewing those things today. We're also going to be solving inequalities. And so if we take a look at both of these inequalities, again, you can pause your video to work through these problems on your own, and then start the video back up to see if you got them correct. But for number 4, I would subtract 6 from both sides. So I would have a negative x is less than 3. But I have a negative x, so I'd multiply everything by negative 1, which means I'd have a positive x. I would have a negative 3, but the sign is going to switch because when I multiply by a negative number, remember the inequality sign switches. So if I were to graph this inequality, it would look like this. If this is negative 3 right here, I'd have an open circle at negative 3, and I would want to shade everything to the right of that, and it would look like that. If I do the same thing for number 5, number 5, the first thing I would do, this is kind of like a three-sided equation. I would subtract 1 from everything. So I'd have 6 is less than or equal to 3/5 x, which is less than 15. And then I would multiply, I want to get rid of the 3/5 x, so I'm going to multiply everything by 5/3. So if I multiply everything by 5/3, the middle, the 3's will cancel and the 5's will cancel. So in the middle, I'll just have x. On the left-hand side, if I want to take 5/3 of 6, I could take 6 times 5 divided by 3. That's going to be 10. If I do the same thing with the 15, 15 times 5 divided by 3 is going to be 25. And so on a graph, this is going to look like this. Here's my 10. Here's the 25. It's going to be, if I read from right to left, read from the middle, x is greater than or equal to 10. That's a closed circle at 10, and I'm going to shade everything on this side. And it's less than 25, which is everything on this side. Now, one thing we haven't talked about yet is interval notation. We're going to get to that here in just a minute, but let me just show you what these would look like using interval notation. This particular graph here starts at negative 3, but it does not include negative 3. And it goes all the way up to infinity and includes infinity. So this symbol here means it doesn't include that number. This symbol here means it does include that number. So if I were to do the same thing with this compound inequality, it would look something like this. I'm going from 10 to 25. That's a 5 there. It does include 10, but it does not include 25. So interval notation for this particular graph would look like that. Let me just be a little bit more specific as far as what interval notation looks like. For regular simple inequalities, if we have x is greater than 5, it doesn't include 5. So we have the interval notation that looks like this, where we're starting at 5 and it goes to infinity. And so and I guess I was wrong before because we could just close those parentheses. When I wrote this as infinity here, that would just be a regular set of parentheses. Because it goes all the way up to infinity, and I'll just close the brackets. If it does include 5, then this sign here, which is like an open parentheses, would change to the brackets. The bracket means that it includes that number. So if I have something like this where x is less than 5, well, it's going to start at negative infinity and go up to 5, but it doesn't include 5, so it would be just a regular set of parentheses. But if it does include 5, that regular set of parentheses would be a bracket because it's filled in and it does include that number. That's simple inequalities. Now, if I look at compound inequalities with the and, then it's going to look like this. If it goes from, let's say, 1 to 5, which it does in this particular graph, but doesn't include 1 and 5, then I have those parentheses for 1 and 5. If it includes 1 but not 5, then this parenthesis would change to a bracket. If I skip down to the very bottom, if they're both included, negative or 1 and 5, then they're both brackets. And then obviously if I start at 1 and I go to 5 and I include 5, then that becomes a bracket instead of the parentheses. So the bottom line here is if I have the parentheses, it doesn't include those numbers, but if I have the brackets, then it does include the number that it's next to. So those are all compound inequalities with the subject and. Now, and is sometimes referred to as the intersection of two sets that looks like this. There's also the or statements, which is a union of two sets, which is denoted kind of like a big, it looks like a big U, but it looks like this right here. And so we have to do these type of compound inequalities with two sets of parentheses or brackets. So for example, if I'm less than 1 and greater than 5, then I would start at negative infinity and go to 1. That would include this simple inequality here. But then this simple inequality here would be starting at 5 and going to infinity. Now, the U here, it looks like a U, but it means union of those two sets, means that the solution would be these two graphs combined, which means it could be either in this simple inequality or it could be in this simple inequality here. And then we have the different, if it includes the 1, well then this bracket here would change, or this parenthesis here would change to a bracket. If it includes the 5, well then this parenthesis here would change to a bracket down here. And if it includes both of them, then they're both brackets. And so now let's take a look at this particular inequality. I want to ask you to solve it and then write it, or graph it, and then write it using interval notation. So to do the first one, I'd probably get rid of the fraction and multiply both sides by 4. So on the left, I'd have 3x minus 3 equals 3 times 4 is 12. Then if I add 3 to both sides, 3x is less than 15. If I divide by 3, I'd have x is less than 5. If I solve the other half of this, I'd probably just start by distributing the 4. That's going to be 8x minus 28 is greater than or equal to 52. Then I'm going to have 8x equals, if I add 28 to both sides, that's going to be 80, greater than or equal to 80. If I divide by 8, then x is greater than or equal to 10. So on a graph, it's going to look like this. Here's my 5 and here's my 10. I'm going to have an open circle at 5 and I'm going to go to the left. I'm going to have a closed circle at 10 and I'm going to go to the right. And in interval notation, let me do this part here first. I'm going to start from negative infinity and go to 5, but I'm not going to include 5. Then the other one, there's the union of these two sets. I was going to start at 10. It's going to start at 10 and go to positive infinity. But I have a bracket here instead of the parentheses at 10 because it includes the 10 where it doesn't include the 5. And so in set notation, or in interval notation, it would look like this. That's what our topic is about today, and that is what our homework assignment is on. It is in MathSpace, and so you can go ahead and click to that link and hopefully have no problem getting that homework assignment done for tomorrow. We will see you then.